Hello everybody and welcome back. Today we're going to be talking about how is the cardiac pump activity clinically evaluated. The cardiac pump activity can be clinically evaluated by measuring the cardiac volumes, pressures and flows. So we're going to talk about the volumes first. The ventricular volumes, which are the stroke volume, which is the amount of blood ejected by each ventricle during one systole, and it's calculated by end diastolic volume subtracted from the end systolic volume, and it's about 70 milliliters. For the end diastolic volume, it is the maximal ventricular volume, or it's also the amount of blood present in the ventricle at the end of the diastole, and it's usually about 120 milliliters. For the end systolic volume, it is the minimal ventricular volume, and it is also the amount of blood present in the ventricle at the end of the systole, and it's about 50 milliliters. For the cardiac output, it is the flow of blood delivered by the heart in 1 minute, and it can be measured by the heart rate multiplied by the stroke volume. The ejection fraction, which is the stroke volume normalized to the end diastolic volume, and it's calculated by the stroke volume divided by the end diastolic volume, and it should exceed 0.55 in a healthy person. Now we're going to be talking about measuring the cardiac volumes. They can be measured by the angiography, which is saline containing a substance opaque to X-rays, which is injected through a catheter threaded to either the left or right ventricle. It provides a two-dimensional projection of the ventricle volumes as a function of time. It also allows the calculation of absolute ventricular volumes. It is the reference standard of ventricular volume measurements. Now we're going to see a picture of the left ventricle angiography. This is another picture with a left and right catheterization. Now we're going to be talking about the echocardiography, the standard echocardiography. It exploits ultrasonic waves reflected at the separation limit between biological structures with different acoustic densities to visualize the heart and great vessels. It has the M mode, which is the motion. It provides one-dimensional view of the heart components. It often yields grossly erroneous volumes. It has the two-dimensional mode, which is the B mode, which is the brightness mode. It provides true cross-sections by summing information from several parallel slices through the ventricle or from planes oriented at a known angle to one another. It also provides more accurate volumes. This is a picture with a standard echocardiography, with the M mode and the B mode. The gated radionuclide imaging provides imaging of the cardiac chambers with a gamma camera after injection of the gamma-emitting isotope technetium-99m. It provides low-resolution images which yields only a relative ventricular volume, and it also allows the estimation of the ejection fraction. Magnetic resonance imaging provides a nuclear magnetic resonance, which is an NMR, nuclear magnetic resonance image of the protons in the water of the heart muscle and blood. It does not provide a good time resolution due to long data acquisition time. So this was everything for today. Thank you very much and hope to see you soon again in the next video.